In this video, I'm going to do one more electrolysis calculations using Faraday's constant. And I'm comparing copper sulfate and silver nitrate. They are both aqueous. And I have a battery that is 5 amperes, and I'm going to run it for 10 minutes. Now I put my two cells in series, so the same current is going through both of them. In this beaker, I have copper sulfate. In the other beaker, I have silver nitrate. Now just note that they are both aqueous. One other thing about copper and silver, they are both unreactive metals. If you look at your potential chart, they require less voltage than hydrogen, so copper definitely comes out and silver comes out. Let's just calculate first the amount of charge that is going through. So I'm going to calculate charge, which is current times time in seconds. And I have 5 amperes multiplied by 10 minutes. I will convert it to seconds, so I multiply that by 60. And when we do that, we are going to get about 3,000 coulombs of charge. Now, remember that Faraday's constant is 96,500 coulomb, is equal to 1 mole of electrons being transmitted. So if you have 3,000 coulombs, you can calculate how many moles of electron is going through your electrolytic cells. And that happens to be 0.031 moles of electron. In case of copper, now just remember copper is 2+, so it will require 2 moles of electron to give you 1 mole of copper. I'm going to put the state of copper as liquid. Now, if that is the case, if you have this many moles of electrons, so let's just look at the proportionality. 1 mole copper requires 2 moles of electrons. If you only have 0.031 moles of electron, we can calculate amount of copper you produce mole-wise. So X happens to be half as much, which is 0.016 moles of copper. Now if you multiply it by its relative atomic mass, 1 mole copper, we are producing 1.02 grams of copper. Now let's do the same case for silver. The amount of charge and electrons are the same, so the only difference is silver is 1+, so it only requires half as much electrons, 1 mole of electron to give you 1 mole of silver. So if that is the case, 1 mole of silver needs 1 mole electron. If you only have 0.031 moles of electron, you didn't need this calculation, but I just do it. Cross multiply, you have 0.031 moles of silver being produced times its relative atomic mass, which is 107.9. You will produce 3.34 grams of silver. So this is a comparison in terms of what quantity of metal you produce in electrolysis, and we are using Faraday's constant. Hopefully this was a redundancy, and now you're becoming expert in calculations.